Hello, everyone. Thanks for joining us today. I'm Stefan Castellani, Head of Marketing at CrateDB, and I'm very excited to have with us Gregor Bauer, our VP Customer Engineering, with us today. We are going to talk about very interesting topic, IoT. With the proliferation of sensors across the different machines, we get a lot of requests from customers asking us how to get real-time intelligence and insights into what is being generated. And that's why Gregor, we decided to organize this live stream webinar today that is broadcast to LinkedIn and YouTube and will be also available on demand after the end of this session. Gregor, nice to have you with us today. How are you?
Thanks for having me. Yes, I'm good. Thank you.
Yeah, so let's maybe get started. So what are you going to present today?
So today we're having a quite broad agenda. So we're going to start with high ingest solutions, millisecond indexing. Then we talk about the data modeling issues, challenges, then also making something meaningful out of the data you collected, so real-time aggregations, then also what cardinality means and why it matters to you. And also then architecture scaling from edge deployments to cloud, feeding AI and ML data to live data. And at the end, I'm also going to do a short demo how sensor data in real time are ingested and you can get real-time insights into the data.
Excellent. Looks very exciting. Looking forward. So let's maybe get started.
Sure. So real-time intelligence. So you can do this with Crate. What does it mean? Actually turning your IoT data into immediate insights. So seeing what you actually get. Maybe let's go to the next slide. So the major struggle all of these IoT systems actually have is not collecting the data. So this is pretty much solved, the issue. So they can all solve it. But getting meaningful information out of it in real time, this is actually the biggest problem. So insights in real time. Because most of the systems are very good at translating all of these different protocols into their database. But querying and scaling, the more data you get, the more sensors you have, this is actually a real struggle. And we're going to talk about that next. So why is it actually so hard? So usually all of these production systems or sensor data, they create continuous high throughput. So you can imagine everyone reports at their interval, a timestamp with the readings they have, and it doesn't stop. It actually gets more because there is more sensor data, there is more information a single sensor can report over time, and when it gets upgraded, maybe software updates and so on. So it will be a huge continuous ongoing stream. The nature of the data is actually time series. So it's not relational data, it's simply timestamp and very granular, and the metrics it actually read. The other challenge is the schemas. So you can imagine you have a software update and then you get new information what the sensor can report, or you buy for the same purpose the sensor from a different manufacturer and they report it in a different format. And if you change it frequently, what most actually do, then you have a vast majority of different schemas. So it's evolving, you need something to adapt to, and of course you don't want fixed schemas usually in the database, because otherwise anytime something changes, you need to do a schema change. Then also exploding cardinality. So cardinality actually means that you have high individual values. So for example, a unique identifier, everyone has their unique identifier, that's a unique value. So in simple terms, nothing you can really group by because it's simple individual values. And you have millions of unique devices, different locations, assets, readings from the devices, and having this in a non-optimized database is usually challenging because the way they index is they try to group as much as they can to find it easier. But if you have a high cardinality, meaning high individual values, there is no way to grouping it. So the traditional search mechanisms, they don't work. So you need something different.
Yeah, it seems to be part of the challenge with time series data to both manage those evolving sensor schema with new formats, so not the maintenance of the database, not having to restart or to change or to maintain over a long period of time. And as you said, the cardinality is something we hear quite often where people want to slice and dice the data in different angles, but without being constrained by this high cardinality issue. Is it correct?
Yes, absolutely.
Excellent. So tell us about what you're seeing on the field with the architecture behind this, because it looks quite simple. You take the IoT data, you want to get real-time intelligence, real-time insight. So on the paper, it looks simple, but in the reality, it's not exactly the way it is.
Yeah, absolutely. I mean, most IoT platforms, they don't consist of a single database or a single backend. It's actually more complex. As we have streaming data, usually they also have a streaming system which takes all these events and streams it to another system. So that's usually first entry point into the backend. And then you have specialized systems for specialized use cases. For example, time series, if you want to query something historically over a certain time frame. You have analytics layers, which query then more in analytics fashion, like analyzing min-max values or getting some insights out of it. And of course, there's also search engines, so traditional full text search, because you might have also text fields in the sensor readings, which need to be searched for with keywords. The issue with all of this is, of course, management overhead. So the more systems you have, the more maintenance you need to do, and the more actually can go broke or can break. And you also have, and this is something which most of the people don't think of, is exploding costs for storage. Because usually the data is actually absolutely the same, but each individual system stores it in their own format. So you have duplication of data, and this costs because you store the same data in different engines. And of course, depending on how you set it up, consistency could also be a problem. For example, if the one has the data already, the other one doesn't. So you are not working with fresh data, you will have a latency maybe, which might lead to different outcomes of your analytics. And of course, delayed insights. So as I said, the more processes you have to put data from A to B in also an ETL fashion, the more problems you have with latency. So you're not working with fresh data, and also theoretically with then inconsistent data. If the one also already digested the data and the other one is still in flight, can happen.
Yeah, and data freshness also directly correlates with data trust. If people feel they have too much delays or too many difficulties in getting access to the data, they don't develop too much trust in this data, and that's also, I guess, is a challenge for real-time intelligence.
Absolutely.
Which leads us to actually to the next slide about what does it require to get real-time intelligence, Gregor?
Yeah. So as I said, the vast majority of sensor data produce a continuous stream of information, and the tendency is, of course, growing. More information from a single sensor being available, more sensors, different sensor, upgraded sensors, it's growing because everyone wants to get more insights. So you need to have something which can ingest at scale so that this is not your bottleneck. So ingest more and more, no problem. The second one is indexing immediately. The reason for this is partly also high cardinality, but also getting these insights. So you can imagine if you want to query new data in a different way because you need that to get some insights, you wouldn't want to index it before, or you might even not knowing what you want to query before you actually do it. So everything which is indexed immediately can immediately be used to get insights. So that's a key component to get these intelligence out of your data, which goes hand in hand with query instantly. So if everything is indexed immediately, then you can also query it immediately. So so that you can actually work on fresh data immediately. And last but not least, support both analytics and search workloads. Also time series, I would also count in here, because then you have a single system which can do it all. So you don't need to query over 3 different systems. You can do it everything in place. So that gives a lot of advantages in terms of architecture, in terms of speed and ingest and maintainability. So this is typically the things you should look for in systems which require like real-time intelligence.
And in terms of range, so what are we talking about in terms of volume and delays for ingestion, indexing time, and query time? I mean, what is a reasonable time frame?
I mean, ingest rates I've seen from thousands, 10,000s to millions of requests per second, and you would need to have a system which scales obviously in that range. In terms of indexing and querying, if you compare like traditional data warehouses, there you can have latency of seconds, if not sometimes minutes, depending on the amount of data which is batched over. So that is obviously the latency you lose. So if you have it immediately queryable, then we're talking about milliseconds after ingest what you can actually read it from. And this is exactly the time difference you gain if it matters, right? For example, in production processes, if you spot some issue only minutes after it was produced, then the waste you're going to produce is much bigger than compared to a millisecond or a second, right?
Yeah, makes sense. And delay, of course, and also the less risk with moving data around from one system to the other is also a big advantage, I guess.
Also, it cannot break that easily if you have a single system. The complexity obviously goes up if you have multiple dependencies, and this is a risk.
Great. So which leads us to CrateDB. So can you tell us more a little bit about CrateDB?
Yeah. So CrateDB is a distributed SQL database. Under the hood is basically Apache Lucene storage system, and on top we have our own distributed query engine. So we really combine the best of both worlds. So traditional SQL as a query language, but under the hood a completely distributed multi-parallel processing framework, which distributes the writes and also distributes the reads from the field. So it's made for real-time analytics, search, and AI. And we can really scale so that we can have ingests to insight in milliseconds, as I said. Any data, any scale. So when we look at the stack, it's basically linear scalability, limitless. So you can add horizontally more and more nodes, or you can make your nodes bigger depending on the workload, but it scales fully horizontally, which is a huge advantage. So you can start small and you can scale up to your workload what you need. Under the hood, we have also full text search capabilities. This comes in hand with our storage engine, which is Apache Lucene. That gives us all the flexibility in storing, indexing, and also full text search, which then leads us to the point automatic indexing. as our system basically indexes everything because we highly parallelize everything, that makes it possible to immediately query everything without any index and performance implications. It's always fast because everything is indexed and everything is parallelized. And we have also on top the distributed SQL engine. So basically, one of the node takes the job of handling. So it can be any of the nodes and is randomly. And then it basically executes these queries completely distributed. Every node gets the work package, what to do, what to query, and then it will be streamed to that node which took the job, and then will be executed, combined, streamed back to the user. So really everything is about scaling and performance at Crate. So I said it before, opt in for simplicity. Of course, if you have multiple systems, that's always a problem. So the traditional IoT stack in terms of architecture, we've seen it, you need multiple systems usually. With Crate, it can be a single stack, single platform, which can do everything. In terms of data movement, you either have streaming processes in between or an ETL process, which adds a latency. At Crate, you don't have to do that. It's zero data movement, zero duplication, zero double costs for storage. In terms of visibility, you might have either historical data or live data. Usually you don't have both in a single system. With Crate, you can do both in a single live operational data platform because we can query the fresh data and the historic data. In terms of flexibility, if you know traditional relational databases, that was always the problem with the schemas. You needed a downtime. And of course, if you have a production system, you want to run it 24/7. So you don't want it to stop just to update for a new schema. You don't have to do this with Crate because the schema is completely flexible. Any data model can on the fly just be inserted. It will all be immediately queryable and indexed. So in terms of architecture, so what we saw in the previous slide, this is the translation of what we can do. On the left side, you see all these different systems from machines, sensors, and so on. You can directly connect them to Crate. So we have an IoT router software which connects and grabs data from all kinds of sources and writes them directly to Crate. So that is typically everything around time series, but it's also asset metadata, geospatial data, ticket data, KPIs, alarms, whatever these systems generate. And you can then directly put it, for example, here into a Grafana dashboard, but Power BI, Tableau, custom dashboards you create, custom web apps and apps is possible, or you get alerts out of the system if something breaks or if it's out of the thresholds you defined. So key functionalities with that architecture, real-time operational dashboards, you can do predictive maintenance, and you can do ad hoc root cause analysis because single system, you can overlay the different metrics and see what's going on.
And this slide, I mean, this architecture looks very simple compared to the complex one you presented at the very beginning. So when you want to install in the real life architecture, is it that simple or do you need additional stuff to connect all things together?
No, it's simple as that. We come with out of the box everything you would need to connect to the sensor protocols, but also connecting all kinds of dashboards. One key advantage what Crate has is we implemented the Postgres wire protocol. So that means all of the ecosystem from Postgres is also accessible to Crate. So you don't need to actually change something if you have a Postgres database, you can replace it with. But also everything, all of your systems you have, they usually have a Postgres connector. So then you can also talk to a crate.
So it's really the implementation of the zero data movement you talked about earlier. So get the data in and make everything out of it automatically and not bother moving it around or transforming the data. Everything is available out of the box.
Yes.
Awesome. So let's maybe zoom in a bit into the different parts of this diagram: ingestion, unified data model, and consumption of the data. So if we start with ingestion, can you tell us a bit more about it?
Yeah. So basically, you cannot stop. So this is the thing. The sensors will report data continuously. And if you don't have a system which is available and gives you the performance and scalability, then you might lose events. And this is the issue. So you need to be able to handle high throughputs, also bursts. So you shouldn't have a system which cannot be quickly and easily be scaled. You might have certain times of the day where you have more events than before, so you need to scale. And so the latency low, and also it must be queryable, because otherwise it's useless. I mean, other systems can also store data efficiently, but they are not able to query it immediately because they have distributed storages and maybe even put that into other warehouses. So it's not efficient. And
which is represented on this slide, where you see all the different types of data coming in and this capacity of querying everything from a single storage engine.
Exactly. Here you see why it is so important to have like a system which can work with multi-models, because the streaming data from these systems are either structured, they're unstructured, semi-structured, or it could be JSON or geospatial. That usually lands in different systems. But of course, if you want to query it, that creates issues because you cannot have a query overall. With Crate, with the flexibility of the data model, it is very well possible to do so because there is no schemas. It's completely flexible. It's evolving schemas, and basically everything is indexed on the fly. So huge advantage in terms of usability. No downtime needed ever.
So very fast and high throughput for ingestion, unified data model or unified storage for different data models. And what about scale?
Yeah. So this is the other thing. You need to be able to scale, of course. Querying at massive scale. The data come in. You need to be able to store them. That's the one thing. But querying is the other thing. If you have a completely distributed system like ours and even a distributed query engine, then there is no bottleneck on single nodes which take queries, because for us there is a truly shared nothing architecture. If you have higher demands, might be for storing or for querying or for complex queries with extreme cardinality, for example, that you have highly individual values or complex queries, then you can just scale. Other systems have the problem that they might have dedicated query nodes or dedicated index nodes. That doesn't scale at a certain point any longer because they are dedicated nodes, they're not parallelized, so they bottle out here. And if you have distributed SQL, that truly is scalable.
That makes sense. And when we see the environment, with the factories, with the shop floors, with the different distributed environments, we hear a lot about the edge concept. Can you tell us a bit more about the edge thing and how CrateDB handles edge versus cloud?
Yeah. So I've seen, for example, also IoT platforms which are cloud only. So that is always a risk because you never know what's happening with the internet connectivity. Could be a very remote location, could be a problem in root configuration or firewalls, which happens quite regularly, and then you lose data. So the concept of having multiple tiers is to be more independent, more resilient, especially in high volume production systems, which need a lot of availability. Moving the data out more and more is actually key to solve these kind of issues. Because on the edge, with Crate, it is possible to deploy very small databases very close to the producers. So we're running on something as small as a Raspberry Pi, so like 2 cores, 2 gig or 4 gig RAM, which is very small. That is where Crate can run. So all these advantages of querying, ingesting, you have at the edge. So then you can kind of buffer the data, and we have something which is logical replication. So you can have from all your smaller edge locations, everything synchronized to a local CrateDB cluster, which then centrally or locally collects all of these edge locations, again, to produce or to get insights into the local manufacturing site, but without any reliance on a cloud or other infrastructure. You can still work on premise. So full privacy, you might not want all your data in the cloud, but still you want to do queries, get insights into production insights. So this is what you can do locally. And of course, if you want, then everything can be in the cloud because it gives you, of course, advantages. Scalability, for example, the more data you produce, you might want to store them somewhere, and in the cloud, it's easily available everywhere. So you can just dump everything there for historical purpose, for more analytics. But this different tiered approach gives you the full flexibility, depending on privacy, depending on latency also, that you need to serve queries very quickly locally, and also in terms of availability.
So the best balance between proximity and flexibility. So depending on the different use cases, of course.
Yeah.
And so we talk also a lot about AI. So AI is a very big word encompassing multiple concepts. Can you tell us a bit more about application of AI to IoT and CrateDB?
So, of course, when you have all this historic data, you can then do multiple things with it. So, the most prominent one is actually training models with that. So, for example, if you spotted anomalies which were handled in a certain way, and then you can extract over time for a certain sensor all the data and deliver it to a machine learning model to train it or to refine it. So this is the one thing which enables you to then to do predictive maintenance on top with the data you collected. That's the one thing. The other thing is AI itself. Of course, I mean, Crate also supports vector data. So all your RAG applications can be done, similarity searches, semantic searches, that's all possible. We also enable agent communication. So you might have situations where your agents are relying on fresh real-time information, actually. And this is what you can do with Crate. So you can feed it, for example, with MCP or CLI to the agents that they can query the data actually in real time, what they would need to, I don't know, chat with your data, get aggregations of the data in real time to have better information available.
Excellent. So now if we talk a bit about the use cases, we see different applications of CrateDB across different industries leveraging IoT.
Mhm.
Can you just touch a bit on these topics?
Yeah. So typical use cases, what we see is, for example, fleet and asset tracking, because we are also having a geospatial search module inside. So that means you can track different routes of drivers. You can track assets within a certain area. So this enables then logistics companies to track, for example, their fleet. And sometimes the manufacturing process requires also that certain equipment is there at a certain time. For example, concrete. Concrete needs to be at the perfect temperature when it is poured and arriving. So you need to keep track of two things: the temperature and the location and the estimated time when he arrives. So this is something what is used. That's one concrete use case. But also predictive maintenance. All of our manufacturing customers do this basically either to get real-time insights to optimize production processes, or predictive maintenance to see before it happens. Energy monitoring, hot topic also with all the ESG reporting, so that we monitor with timestamps and time series data how much consumption we have for certain production items, so that you can calculate it per item produced, how much electricity and CO2, for example. But also smart manufacturing with all our connectors to all these manufacturing systems. It's very easy to collect all of this data in Crate actually, and then get real-time information out of it, like how fast it is produced, where is it, and so on. So typical use cases what we see.
So all of that, of course, I guess, feeds the dashboards, feeds AI application, as you explained.
Yeah.
So there is a large ecosystem. You mentioned a bit earlier the Postgres wire protocol to connect with the Postgres ecosystem. So can you elaborate a bit on the ecosystem CrateDB can integrate with?
Yeah. So from ingest to SDKs to dashboards to ML tools, AI tools, everything can be connected via this Postgres wire protocol. So that allows us then to have also like a real-time dashboard, a unified dashboard with all of your data from a single source to all of your systems. So that's great because then you don't have siloed data silos where some of the data is. You can really query it. You can really see dashboards over all your KPIs. And this is obviously a huge advantage. So seeing everything and calculating everything at once.
Excellent. So we have in our audience a lot of practitioners, architects, data engineers, people involved also with analytics teams. So the question that most people might have is, okay, now we understand CrateDB, we understand the challenges that CrateDB helps solving. How does it fit into a reference architecture? Can you walk us through this a bit?
Mm-hmm. So this is like a reference architecture of what we can actually do. So on the left side, you see, and this is just an example, it's by far not complete. You can imagine with the wire protocol from Postgres, it's much more. But as a summary, we have all these kinds of sensor data, machine protocols like OPC-UA or Cymatic S7 interfaces, which can be ingested over this framework what we have. So sometimes it's polling, sometimes it's being an endpoint, sometimes it's a client, which we integrate into to get data out of it. And basically they're translated and transformed into a SQL query and then put into Crate. So that allows us that machines directly insert data into Crate. So you don't need any other system in between. It's really machines writing their data to a database. And this can be on-premise, but it can also be enriched with much more, of course, with MQTT data, Kafka, all kinds of other streaming services. And you can also directly via SQL insert data or via REST interface, for example. JSON, time series, geospatial, text, and so on. And then you have your local crate instance. Of course, this is not needed if you don't want it. You can also directly talk to the cloud, but this is what we see most, especially also in European markets where data sovereignty is a key topic. They want their data be stored locally, and you can do this. So even if the cloud goes down, you can still process data and query data. And then most of them, they actually do logical replication into a cloud, which can be in the three hyperscaler, also someone in Germany like Stackit, but it could also be your private cloud you maintain. And there you have your larger cluster, big cluster, which you then can do a production line and production side company-wide queries to do predictive maintenance, get your user interfaces on board, and also have your live dashboards with Grafana and all the others. And of course, also get data to SAP because most of the production systems actually report something to SAP. So yeah, typical reference architecture, what we see very often in the market, what they do with Crate.
Thank you. Very clear. So I guess now it's time for a nice demo, isn't it?
Yeah.
What do you would like to present?
Yeah. So we talked highly about you have a lot of sensor data streaming their data to CrateDB. And this is done, for example, in AWS, where we have temperature data. So this is actually real data readings from last year. So we took that from like a public available data sets, and we streamed them to AWS, to their Kafka service. And then we have a Lambda function basically batch writing the events into Crate. And then we have a hosted Grafana dashboard, which then visualizes us the temperature, wind, and pressure readings over time. How it works. Very good.
The joy of life. Life.
Indeed.
Glad
All
we
right,
could figure
so
it
here's
out.
the dashboard. It's empty now, so it doesn't have any data. So what I'm going to start is basically the producer, and it mimics real-time sensors. So they would start basically sending us the data, what they get as readings, and then they report it, right? So what we see here is then really flowing in data. So the only limitation factor we have here is the Grafana refresh rate. So I'm hitting it a little bit more often, and then you can see actually the data moving in. So this is a few thousand requests per second, what it mimics. And yeah, you can see really heat waves coming in from the August reading, what we have. Cool temperature at the sea of Germany here in the north. Yeah, and then more heat signals over time. This is actually not pre-aggregated here. This is aggregated on the fly. So this is also a huge advantage because you can see actually the readings on a map. So it's combining time series data and geospatial data here. And below, it's basically the aggregation functions. So it's querying, give me the average per day, minimum, maximum for the temperature. Same for pressure and wind speeds. We even have a square root calculation on the fly. And you can see how they went in, how the graphs are changing, and so on. So this is really what's possible. Yeah, so that's a small demo. but this is what I call real time. From ingest to insight immediately, because we see exactly when it is sent to the to create the actual data in a dashboard. So this is real time. Massive scale, massive inserts. You can insert and query at the same time to get these insights. That's basically what it is. Yeah.
Wonderful. So, so maybe very quick, we are running out of time, but maybe very quick, and that's something I can present very quickly. So we have many examples of customers deployments across different industries. Here you see some examples of use cases and the type of volume we are addressing with CrateDB and the type of volume also they are generating out of sensors. So as Gregor very well explained, it's quite massive. The challenge is not producing the data. Producing the data is not very easy with sensors. The question is how to capture this data, but how to store it in a way that is easy queryable, taking into account the different types of format and the evolution of the sensor schemas, and making sure we get the data we need with no ETL, with no pre-aggregation, with no downsampling, everything in milliseconds, and also adapt to business requirements change. As the needs evolve, people want to see things differently, develop analytics through different angles, and CrateDB allows to do that with no specific re-indexing work. It's done automatically. So that being said, so I would encourage everyone to learn more about CrateDB and about IoT data, about real-time insights, to go to cratedb.com. You have many things available, a lot of resources, recordings, assets. Also, you can check our GitHub repo where we have also different examples available. And also we have an academy. If you want to learn CrateDB within a few hours, you can sign up for free at the CrateDB Academy, and you can take some courses and get certified with CrateDB. We have a fundamentals course, and we also have an advanced time series course available. So that being said, I would like to thank you very much, Gregor, for your time. It was very interesting, and I hope everybody found it very insightful. The recording will be available on demand on our website later on today, and also directly on LinkedIn and on our YouTube channel. Thank you again, Gregor. Thank you, everyone, for your time, for joining us today, and see you soon. Bye-bye.
It was a pleasure. Bye, everyone. See you.